Okay, so if anyone missed the beginning of the notes, I'm just going to start right from the beginning. On the first page, rigid motions are transformations which preserve angle measure and distance. So you remember transformations from middle school as reflections, dilations, rotations, and translations. But only those that preserve, which means keep the same, angle measure and distance are considered rigid motions. If you need to continue writing and I talk too fast, just pause the video so you can write everything down. Pre-image is what happens before. It's what you started with. The image is what you end up with. So before and after is basically how we think of it as. A turns into A prime if it's been changed. Triangle DEF turns into triangle D prime E prime F prime after it's been changed. There are 4 types of transformations, but 3 of them are considered rigid motions. A reflection, a translation, and a rotation. None of them get bigger. None of them stretch out. None of them change their form. They might move or flip or turn or slide, but they never change their size. They're rigid, they're firm, they never change size. The angles don't change, and the sides, the length of the sides don't change. That's why we call them rigid motions. The 4th one, which you talked about in middle school, was a dilation. That does change size. So we completely talk about that one separately in a different unit called similarity, because the shape will be similar, but it gets bigger. Angles will stay the same, but sides won't. Orientation is a tricky term, and it ends up confusing people later on. Orientation is the order that the points are named. And you only have 2 orientations, either clockwise or counterclockwise. So clockwise goes the same order the clock does. So clockwise would be this way, and counterclockwise would be the opposite of that, the other way. So how does that look in a shape? The orientation of ABC. ABC, A comes first, B comes second, C comes third. So if you follow that, you start with A to B to C, that's clockwise. D, E, F, start with D, then E, then F. D, E, F, that's just the opposite. That is counterclockwise. So that's the difference in orientation. Orientation is the way you order the points around if you did it in a circular motion. So A to B to C is clockwise, D to E to F is like a left turn. If you had a steering wheel, clockwise is to the right, and a steering wheel counterclockwise would be to the left. Of the 4 overall transformations, and we know that dilation is kind of separate by itself because it's not a rigid motion, but which ones have the same orientation? Do they preserve orientation? Which ones have the same orientation? A reflection, if you go A to B to C, you went a left turn. But when you reflect it, the image goes A to B to C, A prime, B prime, C prime to the right. So reflections do not preserve orientation. A translation, in this particular one, A to B to C is going left. And after you translate it, which means you just moved it over a little bit, A prime, B prime, C prime also goes to the left. So in this case, orientation is preserved. Rotations get a little tricky because you might think that it's not, but it really does. A to B to C looks like a left-hand turn with a steering wheel. But after you've rotated it, A prime, B prime, C prime is still a left-hand turn. You started in a different place, but it's still a left-hand turn. So you actually preserve orientation with a rotation. Dilation is a little bit easier to see. A to B to C to the left, A prime, B prime, C prime to the left. So that also preserves orientation. So the only one that does not preserve orientation, or when orientation changes, is a reflection. Okay, the only reason this term is on here, isometric transformation, is because it's a synonym to rigid motion. They mean the same thing. So I just want you to understand, you might see the term isometric or an isometry. You might see the term rigid motion. They mean the same thing. It's sort of just like an old term and a new term. Sometimes you see isometry, and sometimes you say rigid motion. We'll try to use the term rigid motion more. Isometry is just Greek for the same measure. Iso means same and metric means measure, so it just means the same measure. Very similar to a rigid motion. So the three examples at the bottom are the three isometries. We already know rotations, translations, and reflections all preserve distance. They don't get bigger or smaller. The angles don't change. You could cut one out and put it on top of the other and it would fit. That's basically what a rigid motion or an isometry is. A non-rigid motion or a non-isometric transformation, a non-isometry, are your dilations, because they get bigger or smaller. And one that we don't talk about really much in math, but it's technically a thing, we call it a stretch, which is kind of like a distorted dilation. A dilation will be proportional. It will be just an enlargement. If you got a picture enlarged, or if you a shadow got bigger, you would have a dilation. But a stretch means that one dimension will get bigger, but the other one doesn't. So if you look at example 1, this is a dilation. If I make this bigger, it fits right on top. That was a dilation. But in the next one, if I take this and make this bigger, I can make it as long as the other one, but it should have been taller if it was proportional. So it got stretched out in one direction more than the other. That's called a stretch, which isn't really part of the geometry curriculum, but you should understand that it's kind of a distorted, funny mirror type of image. A dilation is what we talk about later in the year. That will be more proportional. A direct isometry is just a direct rigid motion. And that would be if you translated something, or if you rotated something. An opposite isometry, or an opposite rigid motion, is a reflection, because it's still a rigid motion. It's still the same shape. It's just flipped the other way. It's flipped in an opposite orientation. A translation and a rotation are direct. Finish up the notes with this chart. Is orientation preserved? Not in a reflection, but yes in a rotation, yes in a translation, and actually yes in a dilation, even though a dilation is separate. We think of this as a separate unit that we'll talk about later. Isometric, remember, means rigid motion. Is a reflection a rigid motion? Yes. Is a rotation a rigid motion? Yes. Is a translation a rigid motion? Yes. Is a dilation? No. Because they get bigger, distance is not preserved. Direct or opposite isometry. We just talked about it up here. A reflection is an opposite isometry because it looks backwards. A rotation is just turned, so it's still direct. Orientation's the same. A translation, everything's almost exactly the same. That's direct. And a dilation is not even an isometry. It's not even a rigid motion, so it doesn't even fit this chart at all right there. We'll pick it up from there tomorrow, but make sure you have these notes all ready to go.